All right, so at this point, you've had some time to do the build work. So let's look at the solutions. This is a review from what you've learned in Algebra 1 as well as Algebra 2. Let's look at A. To take the square root of 16. First, you should recognize that 16 is a perfect square number. You can get the perfect square numbers by just taking the counting numbers. So 1, 2, 3, 4, etc., and squaring those numbers. So you end up with 1. 2 squared is 4, 3 squared is 9, 4 squared is 16. So 16 appears in that list, so the square root of 16 is 4. For B, 50 is not a perfect square number. However, there is a perfect square number that divides 50. So we can rewrite the square root of 50 as the square root of 25 times 2. And the square root of 25 is 5, so this becomes 5 square root 2. For C, although it's a fraction, if you notice the numerator and the denominator, they're both perfect square numbers. So you can separate the numerator and the denominator. And the square root of 25 is 5. The square root of 36 is 6. And D is a problem that brings us to the concept that we're going to work on today, which is performing operations with complex numbers. So if you put square root negative 81 in your calculator, it's going to say to you error, and it's going to say something like non-real answer. And that's because of that negative. So what we have to remember is that I squared is the same thing as negative 1. So I can rewrite negative 81 as positive 81 times negative 1, and then that becomes positive 81 times I squared. 81 is a perfect square number, so the square root of 81 is 9. The square root of I squared is I. All right, so the question says, which of these is different than the others? So the answer is D, and the reason why is because of what? Right, because of that negative number. So the imaginary unit is designated by the variable I. And you're going to see that in the skill that I'm teaching you today. So this is on complex numbers and imaginary numbers. Complex numbers and imaginary numbers, they're the same thing. So it's sometimes they're referred to as complex, sometimes they're referred to as imaginary. Sometimes they're referred to as non-real. So when you're adding and subtracting, that's pretty straightforward. You can get rid of the parentheses because there is addition involved. There's no subtraction involved. So then when you are trying to add complex numbers, it's just a matter of adding adding like terms. So for example, 5 and 7 are both numbers, so I can add that. That gives me 12. Negative 11i plus positive 4i. When I add that, that gives me negative what? Right. So in this addition, it's pretty straightforward. You can also put this in your calculator. If you look on if you have a TI 83 or 84 plus, if you look above the decimal button on the back on the cover, there's an I above it. That's for the complex numbers. So you can enter the problem in your calculator as it appears here for A, and you'll get the same answer. All right, B. B is a little trickier because there's subtraction involved. So let's get rid of the parentheses. The first set of parentheses, nothing changes. The second set, because of this subtraction sign, it turns the negative 11 into a positive 11. it turns the negative 6i into a positive 6i. And then you combine your like terms. So negative 5, positive 11, that's positive 6. 6i and 6i together, that gives you 7i. So this is my final answer. All right, let's look at I, but the 1 is insignificant, so it's not necessary to write it. D, again, has a subtraction, so when we get rid of the parentheses, it's going to be 2 plus 6i minus 12 plus I. So 2 minus 12, that gives you negative 10. 6i plus I, that gives you 7i. All right, so what have you done in your previous math classes that's similar to this concept? So what should come to mind is when you were combining like terms with variables. So for example, 2 plus 3x plus negative 4 minus 2x. So something else that this is similar to when we get to multiplication is going to be when you have to do the FOIL method. So let's do example 2. Example 2 involves multiplication of complex numbers. So let me remind you that I squared is equal to negative 1. So 4i times 3, that gives you positive 12i. 4i times negative 5i, that's negative 20i squared. What property did I apply? The distributive property is correct. All right, you can't leave I squared in your problem because I squared is the same thing as negative 1. So substitute the I squared for negative 1. So then that becomes 12i plus 20. Usually we write the I, the imaginary part, second, so it's the same thing as 20 plus 12i. But I won't take off points if you don't write it in order. All right, let's look at B. So B is different from A because B you have two binomials. So remind you, binomial is just when you have a polynomial that has two parts. So maybe A plus BX. So it's two parts. A can be considered the first part, BX is like the second part. So you do the FOIL method, which is a skill we practice. So 7 times negative 2, that's negative 14. 7 times negative 5i, that's negative 35i. Negative 3 times negative 3i times negative 2, that's positive 6i. And negative 3i times negative 5i, that's positive 15i squared. So combine like terms. So let's get negative 14, negative 35i, and positive 6i is negative what? And then once you substitute the negative 1 for I squared, so what is your final answer? So it should be negative 29 minus 29i.